I'm actually going to Google it first and see if it's better than I really am. I'm going to try to do better. I'm going to give you the problem and see how many of you can tell me what to do here. No, let's go with an easy one first. Should we go with the easy one first? Yes. 3x squared minus 25x plus 8. 3x squared minus 25x plus 8. All divided by x minus 8. Any thoughts on how to do that? Anybody out there? Ryan?
You simplify the side.
Simplified, it already is simplified. You're gonna say factor maybe. You could. But what happens if it doesn't work out evenly? Actually, in this case it does, but I did that just for whatever. What if this side is not factorable? How would you do that? I'm glad you asked. Here is what you have to remember. Number one, go back to your roots. Ryan's way is actually what you should look to first, because that'd be going to be a lot easier than what we're going to do today. But sometimes it doesn't work, and you have to do what we do for today. And that, going back to your roots, I mean do this. How do you do a division problem? How do you do normal division? Back in 5th grade, do you remember 5th grade division? Well, let's look at one. What if I had 75 divided by 6? You need to think about these steps, because these are the same exact steps we're going to do. What do you do first? You flip this and put this 75 under the division box, right? And you put the 6 out there, right? Yes, Mr. Hahn, that's that word, right? Right. Second thing we followed, always that algorithm. I remember using that word back in 5th grade. What was the algorithm for division? Remember? D, M, S, B. Dear my Sally, be there. I don't know. Was there something we used there? What? I know what it means, but didn't we, was there some word?
Please excuse my dear and Sally, but
That was something else. That's order of operations.
Yeah, geez, come on.
Does math seem boring?
No.
Alex.
It doesn't matter. It just means this. In the process of doing division, you have to divide, you have to multiply, you subtract, and you bring down. You have to think about these steps, because that's what we're actually going to do. We're going back old school with division, and we have to do that. Now, I'll do that. I'm going to do it with this one. Okay, you divide. You divided 7 by 6, you got 1. You multiply 1 times 6 and put it on here. You subtract, you get your thing, and then you bring down. How many times does 6 go into 15? Twice. Boom. And then you can't forget, what do you do at the end? What did I do with that 3? I'm not doing decimals, I'm doing fractions. You took the 3 and put it over the 6. And reduced or simplified or whatever. So it's 12 and a half, right? Yes.
Yes.
Okay. So here you go. You have to take that knowledge, and we're going to do the exact same thing with this. Take a look-see here. And I wish I could do all this. I'm going to start on a whole fresh page. Somebody tell me what that was again. Just 3x squared minus
25x plus 8.
and I'm just going to do it like this right away. Divided by what?
X minus 8.
X minus 8. Okay, so here's what it looks like. Check this out. When you first start, you don't worry about this part just yet. What tells you how to start off is you have to ask yourself, just like with normal division, when I did this back here, I asked myself, what times 6 gave me close to 7? That was where 6 times 1 came from. Well, what times x gives me 3x squared?
3x 3x squared. 3x.
3x. So I put that up there, I put my 3x up there, which is what I did before. That was my division. Now I need to multiply, which means I take this 3x and multiply it by this whole quantity. 3x times x gave me my 3x squared, that's what I wanted because that was the reason I put 3x up there. But now I have to multiply the 3x minus 8, and I get negative 24x. Stop me if you didn't catch that, it was just this distributive property there. That's my multiplication part. Now, here's where everybody goes wrong. If you were bored up until this point, pull yourself out of that boredom and listen to this. Okay, when you get to the subtracting part, you need to actually change both of these signs to their opposite. I'm subtracting this, but I'm subtracting a negative here, so it actually becomes plusing. Or adding. Okay. So you do your subtracting, and what needs to happen is, and this does, these were opposites, so they cross off when you subtract, there's nothing left there. Here, you end up with negative 25x plus 24x gives you a minus x, and then you bring down plus 8. Now the whole thing starts all over again. I did my bringing down, I go back to the top, and you start with this. What times x gives me negative x? Negative 1. And then I do my multiplication. Negative 1 times x is negative x. Negative 1 times negative 8 is positive 8. And then I do my subtracting, which means I change their signs. Tonk, tonk. And then this goes away, this goes away. I'm left with nothing as remainder. If you have something as a remainder, let's say this did work out and there was a 1 left over here, you would have to put that 1 up here, and it's over this whole quantity over here, x minus 8. Because this is the bottom of the fraction. And that would be your remainder there. But there wasn't, so it was just that. It worked out evenly. Now, what Ryan said, when Ryan said, you know, if you wrote this out like this, 3x squared minus 25x plus 8 all over x minus 8, I guarantee you when you factor this, you'll get an x minus 8. If you're taking this, dividing this trinomial into two binomials, you're going to get an x minus 8 and a 3x minus 1 as your other factor. I guarantee you that'll work out, and then this will cross off. It's much quicker to do it that way, but it's not always going to be able to work out evenly, and you don't know that, so you sometimes have to do this long division here. Show us a case in point, you say.
Show us a case in point.
Try this one here. Well, no, I'm going to throw this at you too. Here we go. Here's a problem right out of the book. 2x squared minus 9 minus 7x all divided by negative 4 plus x. Now, when you write this out, you can write this as step 1/2. You may have to arrange some stuff over here. It needs to be written in descending order of whatever we call that. What's it called?
Descending order.
No, we did that whole thing. The order of polynomials. Was it order of something? Not a polynomials.
Order of thought message.
How is polynomial?
Ascending and descending order of. No, there's
Of the parties.
Paw Patrol.
Whatever it is. Step number 1/2, you have to write it in descending order. And you have to fill in any missing spaces, which you'll get to in a minute. This one doesn't have one, but we'll get to one in a minute. So when I write this problem out, the x terms have to come before the numbers, so I switch that around. I get x minus 4. Under the division sign, I write this in descending order, which means I start with 2x squared minus 7x minus 9. If you don't write it in descending order and don't fill in the blanks, you get way confused because the x's won't match up and it'll just mess you up in a large way. So here we go. Just following those same orders of divide, multiply, subtract, and bring down. Does math seem boring today? X times what is 2x squared? 2x. That's my division. I need to multiply 2x by both of these. I get 2x squared minus 8x. The part that everybody forgets to do, I get to the subtracting part, which means these change to their opposites. The 2x squared goes away. 8x minus 7x is 1x minus 9. Oh, look, it's not going to work out nicely, so this will be a good chance. What times x gives me x? Just a 1. So I put plus 1 up there. I get x minus 4. Again, don't forget, what do I have to do? Subtract, which means these change to their opposites. The x's go away. I am left with a negative 5. That's my remainder, and I have to put minus 5 over whatever this was, x minus 4. To me, this is exciting. This is fun. Fun stuff. Very, very fun stuff. Now, what did I mean about filling in blanks, Schwartz? What do you think I meant by that? Take a guess. Somebody? No. Filling in the blanks means this. Maybe one doesn't show up. Nah, we'll do one. It's not on here. How about this, Kayleen Shellhammer? What if this was the problem? What if I had x cubed plus 2 divided by x minus 3? Let's say x. If you have this is what I mean by filling in the blanks. If I'm writing this out long division way, x minus 3 goes here, that's fine. Under the blanks though, under the little box there, you start with your x cubed. You have to, otherwise you'll get very confused. Notice how it goes from x cubed all the way down to 2. And you're asking yourself, well, what about the x squared and the x terms? You need to put them in there. Just make them zeros. You need an x squared term because it's going to, otherwise it'll be way too confusing. You have 0 x squareds, you have 0 x's, and then you have a minus 3. If you don't put those in there, it's just going to make your life incredibly difficult.
Plus 2.
Who's the
It's
teacher
not
here?
right. He knew that, he was just checking.
No, I didn't know that. It was just ignorance at best. So, here we go. Doing the division. What times x gives you x cubed and x squared? You do your multiplying, gives you x cubed minus 3x squared. See, if I didn't put those things there, I'd end up with a 2 up there, and you'd look at that and go, I don't know what to do because it doesn't line up. But now you've got a 0x squared. What do I have to do now? Change them to their opposites because I'm subtracting. The x cubes go away. I'm left with 3x squared. I bring down 0 x's. And then you start, what times x gives you 3x squared? 3x. I now multiply that out. I get 3x squared minus 9x. Change the signs. It opens your eyes. This gives you 9x. You bring down the next thing, which is 2. What times x gives you 9x? Plus 9. You get 9x, I ran out of room. Minus 27. My next step is change to opposites. I actually end up with a positive 27 and a positive 2, which is plus 29 over this. X minus 3. Now, not to be harsh, I'm going to stop this before I say the next thing because I don't want to be on video to say anything.